Namaste. This is Mahesh Arali here. I have worked with Microsoft for close to 16 years and I have 2 decades of industrial experience. A year ago, we started helping skill our youth and we recorded content for Python, Java, and C, C++, and data structures in Kannada. And there has been a lot of requests to record that whole series in English. And here we go. We are getting started with this journey. I will quickly give overview of this course and what's there in the course and what and all you can expect from this course and what you can learn and how it will be structured. So for that, I have just opened my screen, our website. You can go to algorithms365.com. So there we have already a Python programming course from basics to advanced in Kannada. So total, there are 35 lessons and close to 30 plus hours of content. So in this, we have evolution and anatomy of computers, then know your operating system, and then evolution of software industry and roles, then introduction to coding and evolution of languages, pay and perks, write once and run anywhere, developmental environment setup, Python IDE installation. This is all consisting, this all is part of our module 1. So in the English series, we will condense some of it and try to get to the basics of computer and programming languages and evolution of programming languages and quickly jump on to setup of the development environment. In the second module, we have learn to code, and in the learn to code, you have how to master coding, variables, functions, operators, conditional statements, recursion, loops. This covers almost all the things that generally we use other than object-oriented programming. And then we have a very detailed coding workshops almost for 5 hours, 5 to 6 hours, where there are 20 programs that are explained. So we will see if we want to replicate all these 20 programs in English series or make some changes and modifications based on our learning. So the next part is the object-oriented programming. And in object-oriented programming, of course, we'll have introduction to OOPS. In OOPS, we'll have advanced concepts like inheritance, then polymorphism, all of that concepts which are required. And then we'll work on packages and modules, how to use packages and modules in Python. And then there will be a separate data structure course where we'll cover all the data structures that are used by Python. So it will be divided into, of course, 2 courses. Now, along the way, we are adding MCQs, the tests here, and also coding tests. Our platform empowers you to write code on the web. It will run some test cases and tell whether your code is correct. And if not, it will tell which test cases are failing. So once you watch our content, take all these tests, at the end, we will generate a certificate for you. So we are working on setting up those certificates. Right now, it just sees how many lessons you have watched. But since there is an option to say mark as complete, somebody can just go and mark everything complete and they can get a certificate. That's why we have not enabled it yet. We are trying to strengthen the validations. Once that is available, though, we'll enable the certificates. Our basic courses as of now are currently free in Kannada and even in English also, they'll be free. And our advanced courses where we teach full stack, we help with interview preparation, we help in placement assistance. Those advanced courses, the one which are placement oriented, those are all are paid courses. And you can see those prices on our website because they will keep changing and adding offers and all. So you can go and refer those prices on our website. So this is the foundation of this course, and who are the target audience for this course? So it could be people who are studying in their 11th, 12th grade where they have taken computer science as one of the subject. It could be students who are going to enter engineering or who have joined engineering and they have Python as their curriculum in their subject. This could also be professionals who are in industry and they want to learn this language because it's in demand or they want to do some automation at work. The explanation level will be fine-tuned for 11th, 12th grader students, but the technical breadth and depth, it will be fine-tuned for the industrial level. So it will start from very basics till the advanced. That is why we are calling it Python course from basic to advanced. Now, question is basics. A lot of people, when we say basics, the basic starts at hello world. So we will go further down. We will go 10,000 feet deeper than that. We will start literally from the hardware. So that is how this course is structured. I hope you will like it. Please make sure to share about this course. If you are using our Android or iOS apps, please go to store and share your review and feedback. And if you're watching this content on our LMS website, please write your reviews there as well. All this content has been made free. The more you comment, like, and share this content with your fellow students or colleagues, it really helps us to keep running these courses and keep them free for long, and also run only few paid courses. With all this context, let's get started with the course. So if you are learning the programming language, whether it's first time, second time, or you have already learned certain languages, so you may think that, hey, I don't need introduction, let me directly jump into how to declare a variable. So my suggestion is, please don't do that, because I have seen a lot of people have learned programming languages, but there are a lot of technical gaps. There's a lot of gaps in understanding of what that computer it is, how it works, and when you do programming, what happens. A lot of that technical detailing is missing. And what happens is, as you start building and learning advanced concepts, and as you start building advanced scalable softwares, some of the issues that you get, they are at a foundational level. They are issues at network layer, issues in the RAM, issues in the way CPU is handling the load. In your career, as you grow into the senior role, some of the hardest problems you solve, they are system related. So please do not skip this video and watch it, and I'll make sure it's interesting and engaging and fun. So let's begin understanding what is a computer. What is a computer? What are its parts? How it works? What is a programming language? Why it is needed? All of that. So in the initial days, when the computers were designed or built, they were mainly used for research and scientific purposes. And when it was done this way, lot of computations that our scientists need, they need it for, like, say, a space program to send, humans were able to send man to moon. Then there were a lot of satellites, the space programs, and many of these required a lot of computations. And for that, a human or even a calculator was not sufficient, because they had to do a lot of calculations to see the projection of that spacecraft. Now, for all of this is where that computers were born. And initially when they came, they were mechanical. And from the day one, since you cannot have too many alphabets when it is mechanical, the IT industry or the software industry or the computer science always evolved around this language of 1 and 0. I am sure many of you have heard this, which is binary language. Now, why was this? Because of mechanically designing two alphabets for that computer was easy. Naturally, this got transitioned into electrical, from mechanical to electrical, and 1 means it was on and 0 means it was off. So what does on here means? On means there was a flow of current. So there was a flow of electricity, and off means there was no flow of electricity. So it was extremely, in terms of physical constraint and all, it was easy to have two alphabets. Now, in language like in English, you have 26. In other languages, Indic languages, we have 52 alphabets to represent what we want to say, what we want to convey. Now, conveying to the machine with only two alphabet, it means your language, it will be lengthy. It will take lot more alphabets to write a simple message. So in the earlier days, the things that you got done from computer were like simple, simple mathematical calculations. So they would have, like, say, two parts, right? They will have instruction, then value 1 and value 2. So the earlier programming languages were pretty much like this, where instruction they'll say 101 101. Let's say this instruction is for what? Addition. Then you need two numbers. So the numbers were again given in binary. This is a simple instruction to add two numbers. Like this, you had instruction for addition, multiplication, division, and whatnot. For all those instruction, there used to be some unique code, right? So this is for addition. Let's say for subtraction, there was another code like this. Now, these values were mechanically inputted to the computer. So they used to have a punch card. On that punch card, they would make these holes. They would literally take a punch card like this, and wherever you have 0, they would leave it blank. Wherever you have 1, they would make a hole. 1 is there, they'll make a hole, they'll make a hole, they'll leave it blank, they'll make a hole. So on a card, on a mechanical physical card, they would write it this way. And this card was fed into the computer, and computer would do the calculations, and it would again produce the same card for the answer, for the result. And then again they would convert that from binary to decimal. So it was this much cumbersome. And a computer would definitely cost, the amount of space that it will occupy used to be extremely large, like a single bedroom or a single 10 by 10 room or 10 by 15 feet room. So the computers were that large because the capacitors or the transistors that they use for electrical signaling were that big. And hence the computers were very restricted to universities, labs, space programs. They were never meant for common man, common person. The second thing was each computer was designed to do only a certain task. There was a computer for doing maths, there was computer for banking, there were computer for government. The computers were predestined or pre-designed for doing a specific task. You cannot take that computer which was meant for the space some particular thing and apply it somewhere else. They were very designed for specific things. So this is how the thing started. Now you can go to internet, and there is a very wonderful website where they talk about this. It is almost like a library, or you can say it is almost like a museum of computers. Okay, so you can say museum of computer history. Okay, the website name is computerhistory.org. You can go here and you can go ahead and see all the machines that were there earlier. So you can explore and see how those olden computers were, how those the very oldest computers were. You can see all of that here from the very beginning, and you can see this very nice page called timeline of computer history. So in 1930s, what were there, how were things. So it has a very good understanding of Bell Laboratories, the initial set of computers, how they looked, right? So let me just stand here. You can see all of this, and this is that mechanical device that I was talking about. So go and browse through this website, and this each computer, you can see that it was taller than the person themselves, right? So you can see how there is a timeline here. This is at 1942, and now you can see this one. Okay, one second, sorry. So this is 1940s. You can see the evolution of these computers. Just one second, give me a second. So on this timeline here, you can choose whatever year you want, and it will show how it has evolved. So all the way from, you can start from 1930, and they have that pictures. They have that pictures of that. So initial disk storages, right? So how the memory or the storage, it used to be there. Now I happen to have a hard disk with me. So this is how it looked, the initial version, and the current version looks something like this, right? This is the hard disk of the current version. So this is the earlier version, that this is how the hard disk looked. Okay. And so these are, I mean, you can see that a RAM here. Okay, one second. This is very interesting. So this picture here, they are saying this is a RAM, C RAM. Okay. So she's standing there with the C RAM. One second. This is the RAM. That person is standing. Now I'll show you the RAM, and you will be shocked. So this is the RAM now. So you can see the size difference between how that miniaturization has worked. Okay. Now you can all just go and explore this page, and you will see that it is important to know the history and evolution, because then you start appreciating the computer that we all carry in our phones, in our pockets. So this computer is million times powerful than what you are seeing in 1930s, and you will start appreciating this machine if you know how the history of this computers has been. So I would highly encourage. So this is the IBM data module. Now somewhere in 1977, we started seeing a computer like this, which is like screen, keyboard, and some controls, right? So let's see again. Okay, now this is the five and a half inch floppy disk. What you see here is 5.5 inch floppy disk, and luckily I could get hold to one of the next version of floppy disk, which is this. So this is the smaller version of this one. So this, I'm sure many of you have seen. This is the CD player, or CD, where this is a special type of plastic on which, using laser, they used to store the binary information. Okay. So in the hard disk, it is magnetic. It has magnetic disks, and it used to use magnetic technology to mark 1 and 0. Whereas here, this is actually, there are two types of CD. One is where you just write it once and only read afterwards. And there was another CD which was called read write, where you could overwrite it. Basically, it had layers. It had layers, and it would damage one layer at a time. So somewhere in 19. Okay. So this is hard disk drive in 1990s. Okay, and this is the hard disk drive. So this is the 64 MB flash drive. Okay, now somewhere you can see in 1990 is where this hard disk drive came into place. So the round part that you see here is the disk. Okay, and this is the metal disk, that we multiple disks that we have, and this is the needle. So this needle helps to magnetically write ones and zeros on it. Basically, if it magnetically charge it, then it is 1. Otherwise, if you don't charge it, it is 0. And then you have thumb drives. Yeah. So this is really a good website. Good website. I would highly encourage you to go ahead and check it. Now, quickly, let's look into, before we get into programming language, right? Many people have forgotten what are the parts of computer, right? So let's quickly see what parts we have and how things are, right? So I'll slightly keep it tilted. So be it your laptop or be it your phone or anything, you will see this parts which are generally common. So what the electronic board that you see here, the rectangular board that you can see here, So that board is called motherboard, and the one, that fan that you see here inside, that is for the cooling. Okay. Below that fan, you have a processor, because the processor is an integrated circuit chip, a very big chip on that board. It runs computations and it takes a lot of power. Since it takes a lot of power, it heats up very fast. So they have a heat sink on top of that, and on top of that, you have a fan. Now, it may not be visible here. Next to that fan, you see a plastic wall kind of a thing. That is your RAM. Okay. So the earlier versions used to look like this. Now they have also put some cover. So this is a RAM, and it could be that whatever 4 GB, 18 GB, 16 GB, and usually in motherboard you can put these multiple RAMs into the board. And then the hard disk drive on this machine is very nicely packed and is part of this cabin here inside. I'm not going to open it and show it to you because I already have a hard disk drive in my hand. So this is the hard disk. Now, what is the difference between RAM and your hard disk? The difference is this: in this, the information is stored magnetically on the disk, and it is stored permanently. It means even if you remove electric power supply, the information is not lost. Whereas in the RAM, it is stored temporarily. Only as long as there is a power supply, the information will be there. Otherwise, the moment you power off the computer, your information is lost. Many of you have seen in your laptop and phone, you are typing something, you're doing something, and if it is not saved and suddenly your phone gets switched off, you lose that data because the information is stored in RAM, random access memory, which need power supply. Okay. So this is your primary memory. It's also called primary memory. It's also called temporary storage. And your CPU to run and work, the data has to be here. It has to be loaded here, and then it get loaded to CPU, and then it do the computation. Okay. Now you can see that this motherboard has bunch of ports. What are these ports? These are input output ports. Input output ports for what? For reading input from your keyboard, reading input from your mouse, your camera, audio video device, and also send the output to the display. So these two are display ports. So whatever your program is running, at the end it is saying, okay, this is how I want to show that output to the user. Now, these computers earlier were very specific. They were done for a specific purpose. Then came the general purpose. If general computers system, the general purpose computers were not there, then your house will be full of computers. Why? To do UPI, you will have one computer. To listen to music, you will have one computer. To watch movie, you will have another computer. If every computer comes with only preloaded and single program for a specific thing, our houses would have been full of computers. It is like the way we have right now. We have washing machine, dishwasher, then micro oven. Every hardware or every machine is different, right? And we would have ended up having those many, surrounded by those many computers. Thank God that engineers and scientists came up with general purpose computer. The advantage is when you buy a computer, it's blank. You can load the software, you can load the program and make it do the work that you want it to do. Be it listening to music, to taking photographs, to uploading photographs, whatever. And in mobile apps, you go to Play Store and download, you can download hundreds of apps to do different things, because your mobile phone is also a general purpose computer. And this is where the need for programming comes. If the computer is general purpose computer, then how to tell it to do certain work? In the factory, they manufactured and they sent it. They sent the machine. So now you have to talk to the machine, right? How do you talk? You have to talk in binary language. Not everybody is a computer scientist in the world. So the engineers and the scientists, they write the software so that the common man can talk to the computer and get the work done. Imagine you want to listen to a song, and we tell the user saying, no, you write that in binary language like this. How difficult it would have been. And nobody would buy computers, right? Oh no, to you listen to a Spotify song, you have to write this binary language like this. For playing song, it is 1101. And then for this song, there is every song will have some special code. You have to write like this and give it to the computer, then it will play the song. That computers wouldn't have become this popular. To prevent all this, what happened? The software engineers and scientists, they came up with programming languages with which they wrote software. Then they devised these input output devices. What are the input devices? Your keyboard, mouse, and your touch screen and video camera, and even the mic. All this fed the data into computer. Based on this audio, video, touch, keypad, mouse, the regular layman or a human beings can give instruction to computer, and the software which is inside will understand that input and give the output. The output could be again on the screen, or it could be audio, right? Or it could be printout, or it could be some connected device. That is the output, right? So at the very high level, your computer you have here your processor, you have RAM, you have your permanent storage like HDD, then you have bunch of input devices, and then you have bunch of output devices. All of the software and the programs, they are all stored where? They are all stored here in your HDD. So this is where the programs are residing. Your software is residing. Whenever you want to run certain thing, it get loaded where? It get loaded to RAM. And then the processor reads it from RAM and execute that program or run that software. And based on that, what it does? It takes your input, process it, and then it gives the output. So what is the role of a software engineer? Role of a software engineer or a programmer is make this machine useful to the humans. Now on your phone, you can book cab, you can order food, you can get entertained. So the machine is being useful because of this software. If that software and program is not there, then you will not be able to do anything with that hardware. Okay. So this is the main gist of software and programming, and every year there are newer ways of interacting with that machine. The ChatGPT or the generative AI, what it has done is, earlier to interact with computer you needed still some understanding of clicks, buttons, menus, how to open, how to close, all of that, right? Now with Gen AI, you can talk to computer in your natural language. And from 70-80 years, humans have this aspiration that a layman or a common man or a woman should be able to talk to computer in their own native language. See, now I can ask Siri or Alexa or ChatGPT in my natural language and ask it for some information. Ask it to write something for me or do something for me in my natural language. So we are almost there now, where computers are very close in understanding human language and do work for you and respond back in human language. We are almost there. Now you can say that, oh, if that is there, then sir, programming is not needed. Why are you teaching? Why are you taking this course? You may get confused. Yes, we are almost there. We can talk in natural language. So why are you teaching programming to us? That question can be there in your mind. Do not forget that ChatGPT itself is a program. The natural language understanding is also a program. Converting the text to speech is also a program. So whatever that ChatGPT that you are using, it is not the processor that is doing it. There is a program that program is doing. So you still need engineers to build that. We just made computers more easy and understandable to humans, but you need still lots and lots of programmers and software engineers to make these machines work for humans. So with this context, now let's understand why there are so many programming languages. What are the types of programming languages? How they evolved? What happened? So the very first language that came is what? Binary. Binary was hard. Only scientists and engineers could write. So what happened? Then the next language came, which is called assembly. Assembly language. So what is the assembly language? I already showed it to you. So let's say it was like this, right? So they made it little simpler. They said, oh my God, this is a little hard. So instead of writing it like this, Let's write ADD, add. Then instead of writing like this, you said, okay, you write in some format, hexadecimal or different formats. You write it in some format like this. Okay. They wrote the program like this. And how did it work? Let's say before we go further, I have two questions. So there are two people. So one know the language Kannada and another one knows only English. How these two will talk to each other? They don't know any other language if they have to talk to each other. So then you need another person in the middle for translation. Correct? So same thing. The computers know which language? Computers know only binary 1010, and the engineer know only assembly language. So you need a translator from assembly to binary, right? And that translator is called what? The translator is called assembler. So what did assembler do? Converted converted assembly language to binary. That's it. And then the program was given to the CPU. After assembly, then you have high level languages. So like C, C++. Before that, you had something called BASIC, Fortran, right? All of those. So in all of these, what happened is the engineers and scientists wanted to make programming more easier and easier to engineers and students. Okay. Basic code. I mean, I had my first programming language I learned in the school when I was 8th grade was BASIC. So BASIC also used to pretty much, it used to be like this: let A is equal to 10. Then you will say let B is equal to 20. Then you will say sum of C is equal to A plus B. So this is how the BASIC would look. Slightly better than assembly. Now again, this basic language, what it would have something called compilers. So it would take this language, it will have something called compilers, and these compilers compiled that code and converted it to binary. Okay. Now there was a problem. The problem is, in the world, there are multiple companies and research labs. They came up with two different architecture of CPU. One was called x86, another was called ARM. Why it happened? It's just part of competition, human creativity or thinking. So world ended up with two processor architecture. So this was done by Intel. The binary language which was fed to the computer, it need to know what is the processor architecture. Without knowing the processor architecture, that code won't be compatible. So it is as if, like, say, it's a binary, the language is binary, but that hardware machine, it want it to be in a certain way for it to understand it. So that is why there were two variations. If you are using MacBook, the earlier version of MacBook used to have Intel. Now they have M1, M2, M3. And if you go to any computer store where you can ask which processor you want, and most of your smartphones use ARM processor. It takes less power, it has lesser instruction set, so the power requirement for ARM processor is less, whereas this is more. So initial phones, they more all went to ARM architecture because the power consumption is less, the instruction set is also less. But as a programmer, now it is a challenge for you. If you are writing one program, you don't know whether it will run on your customer, will they run it on x86 or will they run it on ARM? That you don't know. It means this compiler, the compilers have to know. So let's say you wrote a C program, okay? Let's say you wrote a C program, hello.c, okay? This is in high level language. You have to convert this to binary. To convert it to binary, what we will use? We will use compiler. Correct? You should know which compiler to use, because there are two compilers. There is one compiler for x86, and then there is another compiler for ARM. Then you will get a final output in this binary, which this guy understand, x86 processor understand, and then this one will produce a binary which ARM will understand. Okay. So literally in my first company where I worked, I used to write code in C. We used to have different compilers for different operating system and hardware. So for that client, we would compile it with the compilers they would give us and give them the binary code or the executable code. Okay. Now there is another thing that happened, which is the CPUs were only 32-bit earlier, and before that they used to be 16-bit bits. Before that they used to be 8 bits. Now most of you on your phone and laptop use 62 bits. So what is a bit? In binary language, this each character is 1 bit. So this is 1, 2, 3, 4. This is 4 bits. Why this is important? You saw the earlier computers, right? They used to be as big as your bedroom, single bedroom. So then the transistors used to be also electrical transistors used to be also very big. The miniaturization started. And then their size started becoming very small, very small. In fact, on this, there is a very famous law. It is called Moore's law. So Moore's law, it says that, every 1.5 years, the number of transistors that you can place on a unit of size, almost it doubles. So the transistor size has been exponentially made smaller, because for every 1.5 year, it is doubling. Like say what the Moore's law is, let's say you have 1 centimeter of space, 1 by 1 centimeter, 1 square centimeter of space. You have 1 square centimeter of space, 1 cm square. Okay. Let's say you could only put 10 transistors in 1960s. So within 1.5 year, it will become 20. Again, within 1.5 year, it will become 40. Then it will become 80. Like that, it has exponentially grown. Now our transistor size has almost, near that atomic level. Maybe 2-3 atoms or 4 atoms together forms a transistor. So it has reached that small level. We cannot go any further than that. The physics limitations, the material limitations come into play. And that is when the engineers came up with a brilliant idea of multi-core processors. You all know, when you go to buy your smartphone to the shop, you will say how many cores? Is it 4 core? Is it 8 core? Or even when you buy laptops, you ask for cores. What does it mean? Because we hit this limitation, now within the processor, there are smaller processors like this. So these are called cores. It's the same part of the same processor, but these are the cores. Coming back to the bits, these bits have evolved from 8-bit to 16 to 13 to now 64-bit. So what is the advantage? You all must have learned it in your college, the binary language. Like say I have this 4-bit thing, right? The maximum value that you can store is how much? 2 to the power n minus 1. If you are using with sign, like say positive and negative, the last one get reserved for the sign. Okay, the remaining get reserved for the values. Let's say you are using for 32 bit, so 0 to 31, and this last bit get reserved for the sign. If it is 1 or 0, it indicates whether positive or negative. Okay, so then you are left with how many bits? You are left with 31, right? So the range of values you can support, let's say 0 is in the middle, this is positive and this is negative, right? So the 0 to 2 to the power 31 minus 1, and here 2 to the power 31 plus 1. This is the range of value. Similarly for 4 bits also, that is the range. So how does it help you? It helps you to do bigger calculations. Point number 1. Otherwise, if you have only 4 bit, the maximum value you can go is only 2 to the power. Let's say you are using only unsigned. Unsigned means you'll use all the 4 bits, right? So maximum you can go is only 2 to the power 4 minus 1. Only that much maximum value you can do addition and subtractions. So it means you cannot use calculations that are required for space programs and other scientific discoveries. So this bits played an important role, 32 bit or 64 bit, and now most of us use 64 bit for our day-to-day use. Okay, there was another important significance of this bit. You know that the CPU or the processor has very less memory. The memory of the processor comes from what? It comes from the RAM that is attached. Correct? Because processor doesn't have, see, in human brain has memory and processor in that same brain together. It's single part within the brain. Our logical thinking and our memory is all here in that gray matter. But for computer, it are two different parts connected by a very high speed connectivity, right? Now, if it is only 32 bits, then to read value from here, every block in the RAM has some address, like our house address. See, you enter any apartment or any layout or any home or any village, in any house in a village you want to go, there is a number to it, right? So you have a street number, then you have a house number, then you have a road number. Like that, if I want to access this location in RAM, I should know the address. And how is the address given? Address is given in the form of number. Okay, this address is in the form of number. If address is in the form of number, the maximum number that you can store is limited by CPU size. If your CPU is only 4 bit, the maximum number that it can ask for or it can read or it can refer is only 2 to the power 4 minus 1. Correct? Like that, in 32 bit, the maximum that it could do was 2 to the power 31 minus 1. Right? So with that, what happened is you can only reference 4 GB of RAM. So in the older operating system, any application could not use RAM more than 4 GB. This was the limitation. And with 64 bit, it can access terabytes of RAM. So there is no restriction. So that is one of the major breakthrough, the shift to 64 bit. Now you don't need terabytes of RAM actually. There is more further optimization in operating system that allow you to store some of that in hard disk and do swapping and all. That will be part of our different lecture. But for now, you understand that the programming language, one variation was x86 and ARM. The second variation is it 32 bit or is it 64 bit? Now, which means your compiler, high level language, from here, the 32 bit, is it 32 bit or is it 64 bit, is separate. Okay. Then within 32 bit, again, what is separate? Again, x86 and ARM. This is separate. Then again in 64 bit, again there is x86 and ARM. Right? Then you have to create a binary output of this. This output is different. This output is different. So if you are a software engineer or a software company, then you have to produce, if you have a software and you want to run it on the computer, then you have to produce these 4 different binary output or the executables and deliver it to the market. Is it cumbersome? Is it complicated? And keeps things, things may keep changing and evolving, and every time that change you have to recompile and send all the 4 packages. And for customer also, they have to scratch their head, oh, which one I should use. Many people, when I ask them, what is their processor, they don't know. Is it 64-bit? They don't know what processor they're using, because they don't have to write. If somebody want to do Word, Excel, PowerPoint and watch YouTube, why should they worry about what is the processor? Correct. So these are some of the drawbacks that Python and Java solved. Why I had to tell you all this is to appreciate what Python is and what Java is, JavaScript is, and even Java as well. They said the programmer don't have to worry whether it is 32-bit or 64-bit or x86 or ARM. We will not worry. On the target machine, we will put one translator. The translator will know what is there in that laptop or phone. The translator will take care of doing the conversion. From here, we will send high-level language only. So what happens in Python? In Python, JavaScript, what happens here is they send the high-level language. They send the high-level language to the computer. And on the destination, they have an translator. Okay. But in technical word, you don't call it translator. What we call it? That translator is called interpreter. Interpreter. So this interpreter converts that Python language from high level language to binary language, knowing whether it's an ARM processor or a x86 processor, is it 32-bit, is it 64-bit. And then it finally generates that 1010 binary language which get executed on the machine. So we discussed multiple things here. The first thing we discussed is how the computers evolved, how the general purpose computers came. With general purpose computers, the need for software engineers came, the programmers came. But then the industry kept on evolving. We came up with, there were 2 different architectures of CPU or processor, then 32-bit and 64-bit. The older languages needed compilers to compile to machine language or assembly language, all of that. And then finally, now we have languages which are platform independent. But it is not all fancy and great thing, because whenever there is a translator in the middle, will it be slow or fast? Let's say 2 people are talking and you want a translator in between. You would have seen, right? Many prime ministers, when they talk, they keep a translator in between to talk between both of them. Those conversations, and of course, they will be slow because the translator has to translate. So similarly, Python and JavaScript, they will be slow compared to C. So many students have this confusion that C and C++ is gone, it's not needed. That is actually a myth. I mean, it's not true. There are many cases where you still need C++. For example, you recently saw a lot of missiles were fired and they had an onboard computer that, stealthily went and hit targets. So they all use embedded systems. And we also, ISRO does a lot of the space programs. They also use a lot of embedded systems. And in all those, they still use languages like C and C++. And in many of the fighter aircrafts, they use C and C++. So a lot of system software like Windows operating system, Android operating system, internally the operating system code is written in C++ languages. And of course, compiled to binary from C++. It directly don't run the C like it runs Python. So it get compiled to binary and get used. But what I'm trying to say is, every language has its strength and weakness. Based on what you need, you will use it. For example, let's say you are going to your neighbor's house, which is only 100 meters. Probably will walk. Let's say you're going to friend's house, which is maybe 1 or 2 kilometers. Maybe you'll take a bicycle. Let's say it is 10 kilometers. Maybe you'll take a bike. Let's say it is 100 kilometers. You'll prefer to go by car. Let's say it is 1,000 kilometers. You prefer to go by flight. And if your friend lives in another planet, maybe you'll take a spacecraft or a rocket. Similarly, what you want to achieve, based on that, the programming language will be chosen. Whether your C is good for it, Python is good for it, Java is good for it. It depends on what is that you want to do, what is that you want to achieve, in which constraint that program will run determines that. So there is nothing like C is gone, the world is run by Python and world is run by Java. That will never happen. So now as a student or as a programmer, you learn one language really, really well first. Once you learn that really, really well, then you can learn other languages incrementally or easily. So in this series, you learn Python really well with good depth and understanding so that you can learn the other languages. So this sets a very good context of the history and background. So what happens when you write a Python program? Let's say you wrote a Python program, hello.py. The extension for the Python program is .py. So this program, to run it on a computer, so this is your hardware. In the hardware, you have everything. You have CPU, you have, let me do one thing. Let me write those hardware parts separately. So let's say this is your processor. This is your RAM. Then this is your hard disk. I'll write hard disk like this to indicate that, disks, HDD. Then you have your operating system on top of this. Then you have your Python interpreter. I'll just say int. Okay. On top of this is your program. Hello dot. I'm just saying hello.py. This is going to be our first program. So what happens when you run this? The hello.py, it goes to the Python interpreter. From the high level language, it gets converted to binary language. And then it asks the processor saying, okay, give me some process to run this code. So then that binary language, 1010 language, is given to the processor. So how is it given? Not directly. Interpreter cannot directly give it. So what it does? It cannot give it directly like this. So what it does? It loads that program here in the RAM, 1010 like this. It loads it here, and then from here the processor will read and run that. And when it is reading and running that, what happens? The processor will talk to your input and output devices. So this is your output device and this is your input device. Let's say you have written a Python program to add two numbers. So your processor will take that input from keyboard, run the program, add that numbers, print back the output on your output. Now this interpreter, Python interpreter, is different for Mac, different for Windows, different for Linux, different for 32-bit, different for 64-bit. So when you are installing Python, when you go to python.org, you will see the options. It will ask, is it Windows machine? Is it 64-bit? It will ask. Okay. So instead of the customer trying to know now, while trying to run on the machine, instead of the developer while compiling they have to do, it is now done at the destination. Okay. So in the destination, they have to install the interpreter based on their machine. Let's say I have an ARM processor and I install x86 interpreter. It will not work. You can try it. You can try it and see it won't work. Okay. So this is how the end-to-end execution of the code happens. Now, when you are installing Python, what are you installing? You are installing this one. You are installing that Python interpreter, point number one. Then you are also installing, I'll write it down here. When you say install Python, what do you install? You install the interpreter. Then you also install standard library. What is standard library? There are a lot of programming things you do very repetitively, again and again, again and again. To save time, somebody has written those code already and you are reusing that code so that it saves time for you. Now within the standard library, there are two parts. One that comes with with programming languages. So one is the default, whatever is come that you get it. The other one is, it's not called library. You can say standard libraries or libraries. These are open source. Open source means someone else has written it and they have made it free. You can use it. So one that is comes with as a part of programming interpreter and programming language, and another one which is from open source. So software engineers, they help each other. They don't want you to rewrite the code again and again. So what they do, they write it and they give it for free. So when you are doing it, you do, and if you do something good, you give it back to me. So that is what the open source is about. I'll have a separate lesson on open source and how to use it. But you have interpreter, then you have library. Then what is the third thing you have? You have debugger. So lot of colleges, lot of places, lot of training courses, they miss on debugger. They do not cover debugger. But you cannot master a coding language without understanding and knowing debuggers. So I will have a lesson on this separately. Then you have IDE, which is an editor. This is something that is not tied with Python. This is separate, but you have to install that. So I will not write it under this. Then other than that, you need an IDE. IDE stands for Integrated Development Environment. Integrated Development Environment. So there is a VS Code and PyCharm. These are two famous IDEs. I will cover that also. I'll show on my laptop how to install them. So what happens is, your IDE is one software where you edit the code, you edit it, and from here you ask the interpreter. You have interpreter and you have debugger. You have debugger and then you have your operating system. So this IDE works with, it talks to interpreter, it talks to debugger, it talks to operating system. When you type the code, it will remember temporarily here, and then when you say save, this talks to hard disk drive. It will talk to HDD, hard disk drive, and save your code. Then when you say run, it talks to interpreter, converts it to binary, right? And then it asks operating system to run that program, create a process and run that program. Okay. So this IDE simplifies the developer life. Without IDE also you can do that. Also I'll show. You can use OneNote and write it and then directly ask interpreter to run it. It will work. But with IDE it helps you to manage your project, your source code. There are a lot of advantages. So if you want to be a programmer, you have to learn an IDE, and I'll teach that IDE as well. Okay. So this sets the very, very, very good context for you to install Python on your laptops and write your first Hello World program and run it. Without knowing all this history and context, if you directly jump to writing Hello World, you will, you'll really not enjoy your coding journey. So I hope you like it. Please share your feedback in the Play Store, Google Play Store comments or Apple Store comments. And if you're watching on your phone, and if you're watching on a website, you please write to us in the comment section. And if it is uploaded to YouTube, please give a thumbs up and share your feedback and comments in the YouTube. Thank you. Thanks for listening. I hope you liked it. Namaskara. ಧನ್ಯವಾದಗಳು.